Bismillah ar-Rahman ar-Rahim. So we are given this problem. Determine the Laplace transform of f of t is equal to t square sine 2t u of t. So if we know the Laplace transform of sine 2t, then we can make use of frequency differentiation property of the Laplace transform to determine the Laplace transform of t square sine 2t here. So according to the frequency differentiation property, according to the frequency differentiation property of Laplace transform, if the Laplace transform of a function g of t is equal to g of s, then the Laplace transform of t raised power n gt is equal to minus 1 raised to power n nth derivative d and ds raised to power n and g of s here. The nth derivative of the Laplace transform of g of t multiplied by minus 1 raised to the power n. So in our case, we know that the Laplace transform of sine omega t is equal to omega over s square plus omega square, and so that the Laplace transform of sine 2t, let's call this g of s here. This is given by omega is 2 here, so this is 2 over s square plus 4, right? So the Laplace transform then of f of t, which is the Laplace transform of t square sine 2t, then this is given by n is 2 here, right? So this is minus 1 raised to the power 2, so dn over ds raised to the power n, and then g of s, right? And this minus 1 square is this is n is 2 here, right? So the second order derivative. So minus 1 squared is simply 1. So this is the second order derivative, d square over ds square g of s. So g of s in our case is 2 over s square plus 4. So so the Laplace transform of the given function f of t is given by d square over ds square g of s, which in our case is 2 over s square plus 4. So let's find out the first order derivative of g of s. So d by ds g of s is given by d over ds 2 over s square plus 4, right? And this is simply equal to 2 d by ds s square plus 4 is power minus 1. So that is 2 into minus 1, then s square plus 4 minus 1, that will be minus 2, and then the derivative of s square, that is 2s. That is 2s multiplied by 2, that is 4s, and that is minus here, so minus 4s into s square plus 4 raised to power minus 2. So that is minus 4s over s square plus 4 squared, right? So this is the first order derivative of g of s. Let's now differentiate it again to find the second order derivative. So d square ds square g of s is equal to minus 4 d by ds s over s square plus 4 squared. So we have a term s term in the numerator and we have an s term in the denominator. So we can make use of this formula, d by ds u over v. The derivative of this ratio u over v is given by, here in the denominator we have v square, then we have v du by ds, then minus u dv by ds, right? So using this formula for this, so we have the d square by ds square of gs is equal to minus 4. We take this common, and this is the v term, so this is s square plus 4. This is already squared, so square of the square will be raised to the power 4. So s square plus 4 squared here, and then the derivative of this numerator term. So this is simply 1, right? And then minus this s term here, the numerator, and the derivative of this the denominator term, right? So therefore this will be into 2 into s square plus 4 into 2s, right? 2s. So this is given by this minus 4 is common, right? So we can take s square plus 4 common here also, s square plus 4, and this will result in this is squared, so 1s square plus 4 is taken common, so we are left with another s square plus 4 here, minus this is, so 2s and this is 2s, so this is minus 4 s square, and this s square plus 4 is already taken common, right? And this is divided by s square plus 4 raised to the power 4. So this s square plus 4 term is cancelled out with this one of these 4 terms here, so this will be minus 4 into, and this will be left with, this will be left with 3 here, so this will be s square 4 minus 3 s square, right? And divided by s square plus 4 raised to the power 3. So we can write it like this: 4 into 3 s square minus 4 divided by s square plus 4 raised to the power 3. So the Laplace transform of the given function f of t is 4 into 3 s square minus 4 divided by s square plus 4 raised to the power 3, or this can also be written as 12s square minus 16 divided by s square plus 4 raised to the power 3. So this gives us the Laplace transform of the given function.